So, hello everyone. Welcome to the webinar on Bactrocera sonata of the Group 1 fruit flies. Let me share with you the presentation first. So, welcome everyone to the webinar on Bactrocera sonata of the Group 1 fruit flies EU priority pest. As you might know, we previously provided the 3 webinars of the EFSA plant pest survey methodological framework and the TUCTIC, including the RIPES and the OptiPest, and 2 webinars of the Group 1 fruit fly Strepsirrhinidae. If you did not attend to the previous webinars and you would like to know more about them, the recorded presentations are available on EFSA's YouTube channel and on the EU Academy website. This is the second to last webinar of a round of 4 that will take place before the summer break, and today's presentations will refer especially to the pest Bactrocera sonata. Lastly, for the new attendees, and as a reminder, since the microphones are mute, the Q&A chat is enabled for you to ask any questions that may come up while the experts are presenting. Let me share with you some housekeeping rules. So you are automatically connect to the audio broadcast, one-way audio, just listening mode, so you cannot speak. The event is in English, and questions should be submitted by email or in the Q&A chat, always in English. In some questions, if some questions remain unanswered, you can resubmit them via email. This event is being recorded, and recordings will be published on the EFSA's official YouTube channel and in the UE Academy. We will send all the information after this webinar. After the event, the attendees will be requested to evaluate the EFSA's event filling out a Microsoft survey. As you see, this is the agenda for today. So now we are in the short introduction, and then I will give the floor to the 2 experts with us today to explain all about Bactrocera sonata. Then we will have the short quiz, I said, with the Mentimeter, and around 11 o'clock, we will get to the end of the webinar. So that's who we are. My name is Jose. I'm the moderator of this webinar. And today with us, we have 2 experts. We have Hans Hermann Tulke. He is the EFSA Pest Survey from the EFSA Pest Survey Methods Working Group. He's the lead scientist at Helmholtz Center for Environmental Research. And we also have today with us Josep Jaques. He is the former professor of plant production at Universitat Jaume I. As I said, we are gonna use Mentimeter just to know who is in the room with us today. We would like to invite you all to participate in a poll to appreciate who is in the room. Please proceed to search www.menti.com with your mobile phone or laptop. And to participate, you can either use the QR code that you're seeing on the screen or enter a code that will be displayed in your screen in a few seconds, and click the join button. Before we begin with the poll, I would like to stress that Mentimeter will be also used at the end of the webinar to display several questions that the experts have prepared to check the understanding of the participants of the content of this webinar. Therefore, it is advisable for you to keep this in mind and have an electronic device nearby to expedite the process. Let's see if the Mentimeter. Okay, sorry, I wasn't seeing it. So as you see there, you have to answer which background you come from. I see some of you are already answering. For those that maybe came later on, you just have to go to www.menti.com and use the code that you have in the upper side, which is 53587292, and just answer for us to know who is in the room today. We can see that most of you are from national plant protection organizations. We have some from central level, from some regional level. We also have some people from support laboratory diagnostics. Okay, so half of you already answered. I don't know if some of you are not being able to use Mentimeter, but it is good for you to know how to use it because we will do a short quiz at the end of this webinar. So let me just briefly repeat that you have to go into www.menti.com and use the code that you can see in the upper side of this slide, 53527292. Okay, so let's proceed to the presentations. So the floor is yours, Hans and Giuseppe.
Thank you. So hello, Joseph. Nice to meet you. How can I help you today?
Well, I need to demonstrate the freedom of a pest in Surveyland, I would like to have your help on that.
Okay, so when I correctly understand, you want to design a pest survey that provides a minimum confidence about the likely absence of the pest in your survey area. Is that correct?
Yes, it's about satisfying regulatory requirements, this and other years.
Okay, then I can suggest you a tool of the EFSA toolbox. Do you have heard about the tool Ripest?
Yeah, of course, I have, but I've never used it. So it would be perfect if we could address this question together. So could we use Ripest for that?
Yeah, that's possible. The application is open access and prepared exactly for the problem like yours. You see the internet link on the slide on the screen. But when we do this, and I'm happy to try that together with you, you have to know a lot of details about your survey area and the pest in particular. Are you prepared for it?
I am, but Hans, sorry, but I cannot see in the screen. I can just see you and me. So are we sharing the presentation?
That's a good point.
Because I can see
You should see.
the two of us. Now, that's correct. Thank you, Hans.
Thank you for reminding me. That's not enough that I see it.
Okay. Now we suppose that all of us can see it. So
Okay, so I'm interested in whether you can help me with the details about the survey area and the pest itself.
yeah, I can provide you. I've prepared some slides for that. But first, could I ask you to please introduce us to what RIPES is, how it would help us with the solution to the survey plan?
Yeah, I can try. So Ripest was made to support us in developing statistically sound and risk-based surveys for plant pests. So where comes statistics in here? The best is if you think about your population that you want to survey as an iceberg. So you can only survey the tip of the iceberg while the rest is hidden. So what is then the outcome if you do your inspection on the tip of the iceberg and you find a pest status that there is no pest present? So what is possible then to conclude about the rest of the population, about this unsampled part? Here, that's exactly where statistic comes in to conclude in this way from the tip of the iceberg to the rest of it. But for this, we need, as always with statistics, a well-planned sample as a basis for this conclusion. Hence, we need a sound survey design to collect these samples. And that's exactly what Ripest was made for, to help us planning these statistical surveys so that we can make sound conclusions out of it. Long words short, let's try to jump into the environment of the EFSA tools. So you see here the first page of Ripest, if you call it, and on this website. And we can immediately start our survey planning. And the first question that you are opposed to is which kind of survey you are interested in.
Okay, and could you tell me what's the difference between these three different types of survey?
Yes, I can try. That's in principle a very simple answer, because the appropriate survey depends on your knowledge about the pest. So if you do know nothing about the pest in your survey area, then you should try a detection survey and test whether the pest is there or not. If during this survey you are finding the pest, then you know the pest is in your survey area. Then your interest is how far it has already spread, which area is infested. So you try to delimit the infested area with a delimiting survey. And if you have delimited the area of pest infestation, you can start mitigation measures and try to prevent further spread. And to test whether your mitigation measures actually are effective, you do a buffer zone survey and you are surveying the area around your infested area, whether the pest spreads further or not. So that's basically what options you have. So which is then the adequate one for your question?
Well, my aim is to detect the pest with reasonable confidence if we had entered Surveyland. And I believe that last year the pest was not there.
Okay, that was last year, but couldn't the pest have been introduced meanwhile?
Yeah, you are right. So I think I would go for the detection survey.
Okay. But still, when you have done and when you have implemented your detection survey, you can still confirm what you have thought from last year. When there is still no pest available, that gives more confidence in your belief from last year. And by this, every year's detection survey will even accumulate knowledge and confidence in the absence of the pest. Okay, now when we have done this choice in Ripest, let's do, then we have to go through different steps of planning for the survey, for the target pest, for the survey area, and for the host plants. Let's start immediately with this. So, what is the motivation of your survey?
Well, to comply with regulatory requirements.
What does this mean?
Well, I need a survey that satisfies detection of the pest with at least 95% chance if it is present with at least 2% prevalence in Surveyland.
Okay, that you see is a statistical conclusion based on a survey sample outcome. Good. Having this, next we have to specify which pest is on your agenda today.
Well, the pest is Bactrocera zonata, and actually have prepared some slides based on the info of EFSA has in different publications. So this is the pest, Bactrocera zonata, which is known as the peach fruit fly. And in the image, we can see a male and a female of this species, the male on the left, the female on the right, and we can easily distinguish them looking at the tip of the abdomen, where we can see the oviscapt in the case of the females that they use to pierce the fruit and oviposit. There's, as I said, the information in this presentation comes from different EFSA documents like the pest survey card, which is actually accessible through Ripest. I think that probably you can show us later. Also the story map on Bactrocera zonata, and also on the pest report to support the ranking of EU candidate priority pests. So from there, I've taken some information, and in the next slide, we can see the life story of some life story threads of this species and the life cycle. So we can see, as I said, the cycle on the left. On the right, we have this table with different parameters. We can see that this species, as all holometabolous insects, has 4 different stages: the egg, the larva, the pupa, and the adult. The larva has 3 different stages, 3 different instars, sorry. And the whole cycle takes about 2 months. Well, in our conditions, we could have the first emergence of adults in late spring. these adults will take like 20 days feeding to mature sexually, and then they would start mating and ovipositing in ripe or near ripe fruit. That would coincide with summer fruit when this fruit is available for oviposition. Then the females would use the oviscapt to introduce the eggs in the fruit. In a couple of days, these eggs would hatch, and then we'd have the larvae. The larvae will consume the pulp of the fruit, and until they can consume the whole fruit. And at the end of the third instar, they will pop out the fruit and bury in the soil where they will pupate. As I said, this process takes about 61 days, and it can continue for as long as fruit is available and the temperatures are above 15 degrees. So this is a multivoltine species, non-diaposing, so it doesn't stop in winter. And under European conditions, the models say that we can have from 2 to 3 annual generations, no more than that. This is a highly polyphagous species. We'll talk about this later. Also, it has a high reproductive potential because one female can lay more than 300 eggs in clusters of 3 to 9 eggs per cluster. And also, it's a strong flyer. So these flies are robust. So they are quite important as invasive. So
Okay.
this is our guest, Hans.
Okay, so then let's look whether the EFSA tool already knows our guest.
Okay, let's see.
So you said
Bactrocera. There it
there,
is.
look,
One. Yeah.
it's there,
Yeah.
right?
Yes.
Good. Was the pest previously reported in Surveyland?
Well, we believe it's not present yet.
Okay, so we put absent. And did you do a survey already on its presence?
No, we haven't. This will be the first one we carry out.
So what then did you motivate you to plan a detection survey?
Okay, well, actually, it's the distribution of this pest. So we go back to the presentation. Here we can see the current distribution of Bactrocera zonata. This is a tropical pest, originally from India and Pakistan, but known to occur in more than 20 countries in Asia, basically, but also in Africa. And it has been detected in Italy, where it is considered transient and under eradication. This is
Okay.
a quarantine pest, and it's a EU priority pest. So,
Okay. Then we need to specify the survey area. I guess that's Surveyland.
yes, that's it.
And why do you think that this pest can become established in Surveyland?
Okay, if we go to the next slide, I'll show you why we think that's based on modeling. Here we have these 4 maps. 2 of them have been produced according to Maxent, and the other 2 according to Climax. That's models that forecast future distributions of pests or potential distributions of the pest. On top, we have the scenario based on current conditions, so 2023, and on bottom, we have the projection for 20. So that's under a scenario of climate change. You can see that the area in color is much bigger than the one I showed you in the distribution. So this pest could establish easily. You can see here in southern EU member states, provided that there's a winter host. This is citrus. So basically in the EU, this species is supposed to potentially establish in southern member states. So the Mediterranean and Portugal would be suitable for establishment. And if we go to your question about Surveyland, if we go to the next slide, you see that Surveyland is located in somewhere in between India and Madagascar. So this is really on the range where this species can establish, and even more easily under a scenario of climate change.
Okay, that is indeed convincing of this threat. So I take this forward as information into ripest. So although Surveyland is not a member state of the EU, I'm surprised that it is also in the EFSA database. So we are lucky. We don't need to do anything than choosing the NUTS 1 region. Perfect. So look, we have everything there. That's Surveyland. And as you said, it is located somewhere in the middle of the Indian Ocean. Perfect. So I think I should select now all the nuts 1 units into the survey, right?
Yes, yeah, because we can consider that Surveyland like a big peach orchard, because the conditions for the cultivation of this plant are quite homogeneous across Surveyland. But actually, I'm mostly concerned about the northern Natswan regions, because these ones are closest to India, so are closest to the places where the pest occurs. And actually, most of our trading centers, we could say airports and international airports and ports, are located there. So I'm mostly worried about these places, and I don't know, can we look at them or could we consider them more carefully?
Yeah, we can. Definitely. We will translate this into a risk factor later. So keep in mind, we definitely will do this. And if you say this now in the right moment, we can also look that we now select the NUTS 1 regions that we want to include in the survey. And I'm stopping here after the 2 northern that you just mentioned. And we see here how Ripus is adding the area. So this part of Surveyland adds up to 22.8 million hectare.
Mhm.
Now I'm adding the rest of the potential knots. And we see in total, Surveyland has an area of 78 million hectare, which is about like Turkey, for instance.
Uh-huh. Yeah,
So when we
learn
have
that.
add them,
Mhm.
we have to specify next our host for the pest. So
Okay.
probably you also have prepared a slide for this,
Yeah.
right?
Yes, you are right. So we will go back to the PowerPoint. Yeah. So this is, as I said, is a species with a wide host range. It has more than 50 different hosts, but peaches and nectarines, so Prunus persica, is the preferred host in the EU and also in Surveyland. So,
And
so
what
it,
makes the pest economically important?
yeah, it is very important. In the images on the right, you can see, for example, the oviposition scars. Remember that I showed you this oviscapt of the female. So just by ovipositing, they produce these scars. Then sometimes the host can react by producing this kind of gum. But then the most important damage is when the larvae are feeding inside because they can consume the whole pulp. So the fruit is completely downgraded, it's lost. And most of this fruit can fall prematurely to the ground. So it's really a very damaging species. And also, as I said, because of its polyphagy, its high potential dispersal, has a high maintenance cost. So all the management that we have to do with this species, if it is present, and then also, if this pest is present, then we have restrictions and quarantine. So it's really an economically important species. And actually, we would select peaches because this is the most important host. Well, peaches and nectarines, as I said, is the most important host in the EU, but also in Surveyland. And actually, this is the host recommended by EFSA in the pest survey card. So,
Okay, then I will do. But I need a Latin name, so you should help me.
yeah, Prunus persica. That's the
Okay,
first one.
this one.
Yeah, this is peaches
Okay,
and nectarines.
okay. Do you have a shapefile of the peach tree standing in Surveyland?
No, I'm afraid that we don't have it yet.
Yeah, no, it's technically no problem. It would only improve the visuality of the final report.
Mhm.
So we can go to the next task that we have to prepare,
Mhm.
which is addressing the target population and the sampling details and the pest characteristics.
Okay, the related information is mainly described in the pest survey card. And here
Yeah,
you
indeed. Look,
that yeah,
there is a link. Does
yeah,
it work?
shoot.
Bactrocera sonata.
It's coming.
Oh,
Yeah,
wow. Look, but you know all this already, so I can close it. But it works. Perfect.
test.
Okay, then let's go. First of all, Aripus is asking us for a shapefile of the environmental suitability. Probably you don't have that either.
Sorry, we don't.
Yeah, no problem, as before. So the next is that we have to discuss more details about the target population.
Okay.
So what is the actual inspection unit of our survey?
Well, this is the target population of the survey, right?
Yes. And what is the inspection unit of the target population?
Well, isn't that what constitutes the target population of the survey?
Yeah, exactly. But I have to know which, because
Okay,
exist
okay,
different. They exist
okay.
different. For instance, you can have the area of a trap or the area
Okay.
under a tree. You can have as inspection unit a complete host individual. You can have as inspection unit also parts of the host plant. So those probably is all depending on the method that you are applying.
Okay, I think in our case, this will be the area of a trap. But let me explain you all the detection methods for this fly. If we can go to the next slide, please. So here we have the two different methods that we can use. The individual tree, where we sample for fruit, and the area covered by a trap. Both methods are valid. However, on the one hand, fruit sampling is more time-consuming than trapping. Samples have to be taken to the lab, and we have the risk of mixed infestations with fruit flies already occurring in Surveyland, like Ceratitis capitata, which is also present in the EU. On the other hand, traps baited with methyl eugenol, which is a specific attractant for males of Bactrocera, so it's a sex pheromone, is specific, and although we still have to transfer the catches or the captures in the insect captured to the lab, it would be simpler and faster than processing the fruit that we collect from a tree. So also very important is that the efficiency of the sampling is double in the case of trap compared to fruit sampling, 20 versus 40%. So that's why we go for the traps, and the inspection unit should be the area of trap coverage, which according to FAO, to ISPM 26, is 100 hectares per trap. So this would be our inspection unit.
Okay, so I have chosen the area, and then the next details that we have to answer is whether the population size can be considered infinite. There's a simple answer: because you want to consider the northern nuts differently, we have to enumerate the inspection units for both parts, the northern and the other part of Surveyland. So we cannot use the infinite approximation here. And the next is that we have to think what is an adequate epidemiological unit for our survey. Maybe it's useful that we go back to what our survey has for components, because we have mentioned already such a lot. So I think an overview would help us. So we have the survey area, we have the epidemiological unit to talk through, we have the risk factors already touched a little bit. We will come back to this. We already discussed the inspection unit, and we had the samples evaluated.
Okay, why do we need the sample and inspection unit in our survey?
So this is to differentiate the survey design from the methods for inspection. So when during the inspection of an inspection unit, let's say like this, there are components of the plant or its environment that are virtually or physically sampled. So you have a sample matrix that you take from the inspection unit. So you could, as we have said, collect the soil under the tree. You can slice 25 ripe fruits from a bush, and you also can cut 5 leaves from 10 branches. Then you have branches as the unit, and the sample are the leaves for DNA analysis. And you can send, as in our case, I guess, you can send your trap catch as the sample from your inspection unit, which is the trapping area for the laboratory to identify the pest imagos. So that means the sample evaluation that follows a method protocol that provides us with a hopefully high probability to detect the pest in the inspection unit from which the sample was taken. Good. So
basically, we already have the survey area, which is Surveyland. We have the inspection unit, which is the area covered by a trap. So this 100 hectares. Plus we have the samples, which is the trap catches, right?
Right. And what we can specify next is the epidemiological unit. The epidemiological unit that would be adequate for your problem should be beyond specified risk factors that you already know, where you actually can quantify the difference. Beyond that, the epidemiological unit should form a homogeneous area where the interactions between the pest, the host plants, and the abiotic and biotic factors are similar everywhere. And in particular, also, the management must be equivalent across all the epidemiological unit. So could you give a suggestion then for this problem?
I think that we should consider Surveyland as a large peach orchard. So the best epidemiological unit for this fly is a large peach orchard. Pest conditions are expected to be similar across the whole island, same as the management, which is IPM. So I think we should choose epidemiological unit that is a big orchard, peach orchard of Surveyland.
Okay, so having this, we can enter our user-defined epidemiological unit. We want to have one, and we call this Surveyland, as you said, and we have to give the number of inspection units. Should we calculate together the number of inspection units?
Great.
Yeah, okay, so then what do we know? We know that Surveyland has 78 million hectares. What percentage of this area is actually covered with peach trees? Do you
We
know?
could say that, yeah, about 1%.
1%. Okay, 1% of 78 million creates 783,600 hectares with with our peach trees that we have to divide into covered areas by traps. So you said 100 hectares is a trap covering?
Yep, that's it.
So then we're ending up with 7,836 potential inspection units that we can equip with a trap. Okay?
Okay.
Sorry.
Fine.
So then we can put 7,836 here, and we are done with the inspection units. Now the question comes back to the risk factor. You were intending already in the beginning that we should consider this kind of issue. So we say yes. And you were saying you want to consider the relatedness of the northern nuts. So I don't think it's about the spread capacity of the insect, but there are others. So which risk factor, how we should name our risk factor? What is the aspect that we want to consider?
Well, in our case, it was the distance to the infested countries.
Yeah. And do you know how this will help us? I started it already in the beginning, but when we rethink what we can do actually with this risk activity, so maybe that is more helpful to understand also how we can define our risk factor for the northern nuts as well. So when you have a biotic or abiotic factor that can be related to the environment or to human activity that is potentially increasing the likelihood to detect the pest within this epidemiological unit, and you know where that is, and you know on which area it is, then we can use this information to optimize or to make our inspection unit distribution of inspection units more effective. So in our case, you want to detect the pest if it was entered just before the survey. Then it would be more useful to concentrate the efforts in the area where we would expect a high probability that the pest is there. There could also be other ways to use this risk factor. When you think about a delimiting survey, for instance, where you want to know the area where the pest is, you know it is already there, and you want to find where it is, then you can restrict sampling in risk areas because you know the probability to detect there is higher. So you see different problems relating different risk factor interpretations all together to a better use of the necessary inspection units that we have to consider. So when we now go back to our problem, so as I understand, we will take one risk factor.
Yes,
Yeah?
that's it.
So
Yeah.
you say
It's the
it's
north.
about the northern nuts, right?
Yes, that's it. The two northern nut
And
ones.
the risk issue is that they are so close.
Yeah, closeness to infested countries or areas. So
Okay, so the risk factor is in, and later we have to quantify your knowledge. Yeah, that's the point why we can use a risk factor in the epidemiological unit that should be, according to our other aspects, homogeneous. So the next problem that we have to consider is the survey site. So when I read what is proposed here, I think what you said is pointing to the orchard.
yes, that's correct.
Okay. And what's about the survey time? So you were saying something about summer, right?
Yes, because we are trapping adults and the adults are active mostly during the summer. So I think if we survey from June to September, that's when we have summer fruit, like peaches. It's the most important period. So that would be great.
Okay. So now we have basically done our survey.
Great.
Everything is there. Everything is mentioned. Now it comes to the quantification.
Okay.
Because when we want now to calculate the number of inspection units for a sound statistical conclusion, we need to know how good your detection method perform and how good they are identifying the pest. So that means how effective is the catching and afterwards the identification of the insects from the trap catch. So that's what we have to address next. Because the method that you are applying on the inspection unit towards the detection of the pest has a sensitivity. This sensitivity is the probability to detect the pest when the pest is or was on the inspection unit. And this method sensitivity is divided into components. One is the sampling effectiveness. That's the way how these samples are taken from the inspection unit and keeping the pest in if the pest is on the inspection unit. And after, it is combined with the diagnostic effectiveness or the diagnostic sensitivity. That's the probability to find the pest in the lab when the sample is provided there and contained the pest. So with this two, we could calculate the method sensitivity, and the method sensitivity would tell us whether we need more inspection units to inspect to compensate for lower sensitivity. So can we think about the details that would help us in this regard about sampling effectiveness and the diagnostic specificity?
Yes, as I already showed in previous slides, the sampling effectiveness of the two methods we could use is 20 and 40%, 20% for fruit sampling and 40% for the area covered by a trap. These values come from a recent ECE performed by EFSA. So this is the first result we need, 40% for the traps. And then in either case, we should take all these insects to the lab for identification, and the identification could be based on molecular methods or on morphological. The effectiveness would be close to 100%. Of course, we have to consider some possible mistakes, so should be close to 100%.
Okay, that seems sufficient for what we need to say. So first of all, we need to know which detection method we are using. You said insect traps. Now more details are, what is the type of trap here?
It's a pheromone trap because methyl eugenol is a sex pheromone, a male attractant.
And then which trap type you will use in your survey?
We could use bucket trap. We can also use delta traps. We saw them in the images, but here that's fine.
Okay. So what is our sample matrix? We look, what is there? Because we want to have the trap catch as our sample matrix. Good. And you said 40% is the method.
Sampling.
Yeah, it's
Yeah.
the sampling effectiveness.
That's it.
Okay. So now we have the trap catch and we move it to the laboratory and they have to identify adult insects. Is that correct?
Yes.
So they do it in which method?
Topological methods, that's one possibility. Then we need a microscopic inspection or examination. And it will be based on light microscopy. We don't need to go beyond that.
And the diagnostic sensitivity you said is nearly 100%. How is that possible?
Yeah. So I think we could take 98% to consider that it's not 100% effective.
So it is. So when the insect is still in a good condition, then it's quite straightforward, right?
Yes, but consider that we're taking these insects from the trap, so we may have some problems. So we could go for something lower, like 98%. For
Okay,
example.
then put 98% here. So we are done now with this section, as I understand, right? It comes now to the design phase.
Okay.
What comes now is the critical part of, so far we have constructed our survey. Now we have to specify how we want to interpret and what we expect from the survey as an outcome. In principle, we are now talking about two quantities that are in the remit of management decisions. And of course, we have to specify our risk relation between the northern and the southern nuts. So the confidence level, you said 95%, right?
Yes. That's according to regulations.
Okay, the confidence level is what is the expected confidence in the final statement of the survey. And then we have the design prevalence. What should I take there?
Well, again, according to the protocol, we need to use 2%.
So do you have discussed where this 2% came from?
No, I just took it from the regulation, but if you could better explain where it comes from, that would be great. Hans.
Of course, I was prepared on this question and I have prepared a slide for this. In principle, it is important to understand that there is a quantitative relationship between the number of inspections that you have to do, here printed on the x-axis in this diagram, the achievable confidence level in your final statement, and the assumed design prevalence. So what does this design prevalence mean that we assume? It is the minimum prevalence of the pest in the survey area that is detected with 95% certainty. So if you take, for instance, 5% as design prevalence, the red line, that means 5% of your population is infested. So if 5% of your population is infested, then you will detect this with 95% probability. But before we come to this, we start with the number of inspections on the x-axis and rise their amount, from 0 towards 100. And you see how the confidence level with the same design prevalence is already rising. Now we can specify what we want, 95% confidence in the final statement. Then we can read from this relationship between the number of inspections, confidence level, and design prevalence that with 5% as the detection limit, we need about 70 inspection units to inspect. The point is, if we now shrink this and say we want to detect it already when there is 1% with the same confidence, with the same 95%, then you see on the green line how this cross point is moving to much more sample units in inspection units. Now we are at about 380. And if the management is requiring even more safety and wants to have detection of the pest already if it is only 0.5%, so the blue line, then this diagram doesn't fit anymore because it's much more than 500 samples. If you continue the curve, you see it's somewhere crossing the dotted line out of the diagram. So now you see the quantitative relationship between the two. But could you imagine a useful way to think about what this prevalence actually is?
Well, I think as you have written here, this could be a function of what we can still eradicate in our case, right? So
Yes.
it would be a nice way of thinking of this prevalence instead
Yes.
of this
And the
2%.
question immediately is when we want to translate it into the maximum prevalence that still can be eradicated, that we then can use as design prevalence, then the question is it actually possible to eradicate Bactrocera zonata?
Okay, if we go to the next slide, you'll see that based on a recent ECE performed by EFSA, the experts concluded that the surface of a 1 kilometer radius infested can be eradicated by one plant health emergency team using all the methods that we can see here: chemical control, sanitation, limitations to the movement of commodities, etc. So this is what could still be eradicated. And then 1 kilometer radius, this equals to 314 hectares, right? Because we have
Okay.
a circle. So
That makes me immediately thinking about my desk calculator. So when we make a percentage out of 314 hectares from 783,600 hectare, then the applicable design prevalence would be 0.04%.
wow,
It's
but this
high.
would probably, this would probably require a lot of resources. And I'm afraid that Surveyland cannot afford this. So,
Yeah, so what's with our nice parallel? But maybe Surveyland can activate more than one emergency team to treat infested areas.
okay, then how many teams would be needed if 2% of the area is infested?
Okay, well, again, let's ask our calculator so that I don't make a mistake with small numbers. So when we have the total area size and we want to have 2% out of this, then this is 15,600 hectare. And now you say each team would control and eradicate the pest from 314 hectare. So then Surveyland has to provide 50 emergency teams.
Wow, that's a lot. So I'm not sure that this is feasible either. What we know is that, well, we have 6 NUTS1 regions in Surveyland, and each has an average of two emergency teams per NUTS1 region. So that means that probably the best we can do is 12 survey or 12 eradication teams. So
Okay,
what could we
that's
do with that?
that's an interesting proposal. Then these 12 can do their 314 hectare, which makes 3,768 hectare. And we divide this now make it as a percentage of this our total area. Then we end up with nearly 0.5%. That's by chance the blue line of the diagram I saw before.
Yeah.
Okay, so we have a value which is adequate for a practical capacity of 12 teams in such a big survey land. And we have the regulatory requirement that requires a lot of investment in new emergency teams, exactly 50 in this particular case. So what I propose we ask RIPES with 2 values, these 2, and then you take the results of RIPES and discuss the implications for the implementation decision with your management. What do you think about this solution?
Oh, I think that's great. because then we can compare and talk about what we can actually do and how to best use our resources. That's great. Thanks.
So then we start with the 2% from the regulatory part. And the last thing we have to specify is now our risk factor.
Okay.
So we have two levels,
Yes.
right? Yeah. So we have as high risk, we have the northern knots.
Yes.
And as a baseline, we have all the other nuts. Well, then the relative risk. What is the relative risk? How we can catch this? Do you have interceptions? Sorry. Do you have interceptions?
We do. So if you go here you can see the two zones, the north, which is 29% of the orchard, the island, and 71%, which is the rest. As I said, the reason for this distinction is the closeness to infested areas and also the presence of main international ports and airports there. And actually, we have some detections. So if you go to the next slide, you'll see that from 21 interceptions that we have of Bactrocera zonata, 19 correct. So probably the relative.
So you have, sorry, you had 21 interceptions?
Yeah.
Yeah, okay, and 19 in the northern nuts. Okay, so then this is a risk relation of 10-1. Straightforward. That's nice. Very good data to help us. So we can quickly switch that in. So you say 10-1.
Yes.
And then we have to know the percentage. And just I glanced this on your slide, so you prepared it well.
Yeah.
So we have 29 for the northern percent of the area and 71 for the others. Correct? Okay, so then we are quickly done here with a usually quite complicated problem. And you see, Ripest was observing that we do everything right. Now the warning is disappeared. And in our particular case, we want to have a convenience sampling because we want to focus effort into the risk part, in the risk part of our epidemiological unit. So now we are through. Ripest is prepared to give us an answer. But before we do this, I ask you to check whether all the details that we collected are correct and you would accept them.
Okay, inspection units, target population size, sampling matrix, sampling effectiveness, sensitivity, design prevalence. Yes. And that's correct.
That's correct.
If we are
good,
that would be great. Yeah.
So then we ask Ripest what would be the result. And what you see here, I hope you can see it. We get for the two risk levels, the high risk level and the low risk level, the population size or the target population size that falls in the particular part of Surveyland. And then we get the calculated number of inspection units, 130 and 65 for the baseline. And we also get an indication of the achieved confidence level from the individual areas. So remember 130 and 65, right?
Yes.
Now we produce the other result. There we said we want to have it 0.5%. We do. We simulate again. And now, did you see it? How it was changing? Of course, the population size is the same. And the samples are incredibly increased because now we want to detect it already with 0.5. Yeah?
Okay. Yeah.
Good. So that's basically the result by which you can go then to your management. But I don't want to withdraw from you the result when you have done your survey. Look, we can skip all this because we want to go to the end. So if you have implemented your survey and you found the pest, and you will put in what you have here, what you have done, then of course Ripest will tell you, now you have to do a delimiting survey because you found a pest. Okay? The lucky situation is you do not find a pest that we choose now. then you have to say that you actually have 510 negative samples from the risk area and 255 samples, negative samples from the baseline area. And then you can calculate the final result that looks like this. Yeah? So you have repeated the information that we have seen before, the number of theoretical samples, the theoretically achieved confidence, the number of negative samples, numbers that were not determined, and the finally achieved confidence level, which would depend a lot on this, how many undetermined samples you have. And the final conclusion tells you that the survey area is free from the pest based on a survey with confidence level of 95 point something percent and the design prevalence of 0.5%. So that's what we get from RIPES. And if we put that together, then we can compare, and that's what you have to explain now with in the implementation discussion, when you strengthen the detection towards 0.5 instead of 2. So, and then you have to sample this amount of negative of samples, and when you relax it to the 2%, then you have less samples, but of course you end up with an infested area where you need 50 teams, so you have to invest in teams. That's
Okay.
what I can
Well,
give you. I hope that helps.
yeah, very much so. It's really helpful. So thank you very much, Hans. I will now have to discuss it with the managers. Thank
Good
you.
luck.
Thank you.
So thank you, Giuseppe. Thank you, Hans, for your presentation. Was really interesting. Was dynamic and didactic. So thank you very much. Now is the time for doing a small quiz. Do not worry. It's just to see if the presentation was understood. So take it as a game, a small game, not as an exam. So for that, we're gonna use again Mentimeter. I explained before how to use it, but I will remind that it's like you have to go online and put www.mentimeter.com, and you have to use the code that you can see in the upper side of the slide is 85522963, or you can either scan the QR code that you are seeing on the screen. So we are gonna do this small quiz to see if you understood, and then Giuseppe and Hans will give us the correct answers. So for the first question, how many generations of Bactrocera zonata are expected in areas of the EU where the pest may become established? We have four options, so no more than one, no more than three, up to 10 because this is an multiple time species, or Bactrocera zonata is not expected to establish in the EU. So I see almost 100 of you already responded. For those that don't know yet how to use it, I will repeat. You have to go with your device, electronic device, and www.menti.com and use the code that you can see in the upper side of the slide, 85522963. I'll give you a couple seconds more to answer. Okay, so most of you think that the correct answer is no more than three. Let's see what Joseph and Hans think after the small quiz. So let's go for the second question. Which type of attractant is recommended for Bactrocera zonata traps? We have four options again: a sex pheromone, a food attractant, an attractive color, or a combination of all the above. I see more of you join the Mentimeter. I hope the other ones were not afraid to to do this small quiz. but you can join us in the menti.com and use the code that you can see up in the upper side of the slide. So, wow, most of you answered the first option, a sex pheromone. Let's see what the experts think after the quiz. Let's go for the third question. What is an appropriate inspection unit for Bactrocera sonata surveys? So, option A, the area covered by a pheromone trap. Option B, an individual peach tree. Option C, 1 and 2 are correct. I give you a couple more seconds to answer because almost all of you answered already. Okay, so whoa, we have divided opinions here. So I'm sure they want to know what's the correct answer. Let's go for the last but not least question, the fourth question. What is the correct design prevalence of the detection survey of Bactrocera sonata? So 3 options for this one. Option A, known. Option B, 0.04%, or option C, 2%. People is answering really fast in this one. Almost all of you already answer. I give you. Okay, so most of you think it's the option C, 2%. Let's see what the expert think about your answer. So Josep and Hans, please give us the correct answer.
Okay, shall we start by the first one?
Sure.
Okay, so for the first question, how many generations of bee zonata are expected in areas of the EU where the pest may become established? Was option 2, because according to the climatic suitability models, 2 to 3 generations are expected in southern EU member states where citrus, the winter host for Bactrocera zonata, are grown. So 2 was correct, and I think that most of you chose correctly. Then the second question, which was about the type of attractant, the right answer was A, sex pheromone, because the traps contain methyl eugenol, which is a male attractant, so a sex pheromone, which is specific to Bactrocera. So, and again, I think that most of you chose the right answer.
So let's go for question 3, Hans. This was really none all of them were
No, that's fair.
yeah, they didn't really know which one of the 2 options choose because they were divided in mostly in 2 of the options.
Yep. So the correct answer is C, and this was only in one slide presented by Josep, where he was talking about the other potential methodology to inspect for the pest on the individual tree, taking the fruit as the sample. So that means, in principle, he was saying that in principle both approaches were useful, while for the large area, which we did not say in our question, for the large area that we had treated in our webinar, there it would be more effective to use traps. That's why we're using, but the appropriate inspection unit is either or. And the third question, the fourth question, that was made to make you answering as you did. So you all were ticking the regulated 2%. But the question is asking what is the correct design prevalence of the detection survey? And the word here is correct. And we have discussed that the design prevalence and the confidence limit is a managerial decision. So in principle, there is no correct design prevalence because it's depend on what you want, when you want to detect it, and by what confidence. So therefore, it was actually correct to take A. There is no correct design prevalence. Thank you.
Thank you very much, Josep and Hans, for your presentation and for these answers. And now we're coming to the end of this webinar. So I want to thank you all for coming today. I'm glad to share with you that we were more than 200 attendees today. In case we did not manage to answer all your questions, you will find them published on the EUA Academy. Please note that similar questions will be grouped where possible. The recordings of today's event will be able on the EFSA's official YouTube channel and in the EUA Academy with subtitles in 4 different languages: English, Spanish, French, and Arabic. Next webinars will take place on the next dates will be group 1 fruit flies. The last one of this group will be Ragoletis pomonella, and it will be the 30th of June. And then we will have more seminars for group 2, and they will be in September 18th, the Anaflora kinesis, and then in September 30th, it will be the Anaplophora glabripenis, and then in October 27th, Aromia bungi. So I want to thank you all for attending our event, but I would like to please take a few minutes to scan the QR code that you're seeing on the right side of the slide and fill in the evaluation survey. If you are unable to scan the QR code after the event, you will receive a link to access the Microsoft survey form. Your feedback is essential to improve our future events, so please, I encourage you to answer this survey. And that's all for today. Thank you everyone for attending this webinar, and thank you once again, Hans and Josep, for their presentation. We have now reached the end of the session. I hope you have all learned about this pest and are now well informed about it. As I mentioned in the previous slide, the next webinar is scheduled for June 30th, and I hope you can all attend. Thank you and have a wonderful rest of the day.
Thank you. Bye-bye.
Bye-bye.